In this video, we're going to briefly review how to do adding, subtracting, and multiplying of complex numbers. And so let's start by looking at what does it mean to be a complex number. You're welcome just to watch this part. 2x squared plus 4 equals 28. So if you were going to solve this simple two-step equation, we'd start by subtracting 4 from both sides. Simple enough. And we're going to divide by 2, and we get to 12. Now, what we talked about yesterday was this tells us we're going to have two answers. And we achieve those answers with plus or minus, but we can't leave it as the square root of 12. I'm going to write down the perfect squares, and I'm going to stop when I can see where 12 lands. So 12 is right in between 9 and 16. These numbers are achieved by taking 1 times 1, 2 times 2, 3 times 3, 4 times 4, and so on. So I need to see, can I break up the square root of 12? So grabbing a calculator or using mental math, I'll do a calculator for those that are visual learners. I'm going to take 12 and divide 9 into it. It's not a pretty answer. I know that 9 does not divide nicely into 12. 12 divided by 4 does work. So I'm going to break 12 into 4 times 3. And now I've achieved the answer of, we have two solutions. They're both real because they contain no I. But I want to stop for a second. I want to review a common mistake I see students make. They get to this part right here. They take the square root and they get x equals plus or minus, and then they're trying to break it down and they go 6 times 2. Please turn to the person next to you, and in 5 seconds, please tell us, why can you not break that down into 6 times 2? 6 times 2 is 12. Why can we not break down into 6 times 2? Neither 6 or 2 are perfect squares. So they will not break down like the square root of 4 breaks down into 3. So when we break it down, one of the two must be a perfect square. Let's try another one. Okay, so for this one, I'm going to start by subtracting 2 to both sides. And you know what? I want to stop you for a second. I purposely wanted to achieve a certain type of answer. Can you please go back and make that 20 into a negative? And I get a negative 24. I divide by negative 3. Remember that two negatives make a positive. And again, we're just working on that skill of how do we break this down. I'm going to have two answers. I cannot leave it as a square root of 8. That's not in simplified form. So I'm asking myself, what perfect square divides into this? So 1 times 1, 2 times 2, 3 times 3, and so on. 8 lands between 4 and 9. And so I'm going to start with moving downwards. Can I take 8 and divide it by 4 and get a nice answer? I sure can. So I'm going to break 8 into 4 times 2. The square root of 4 is 2. And this is my final answer. Now, what if I just slightly change this? So now I'm going to have you do the same problem, which means you're probably going to get an answer that looks much the same, but it's going to look like this. 4 plus 3x squared equals negative 20. Go ahead and solve this one, please. All right, so I'm going to start this two-step equation doing just like you learned in 8th and 9th grade. Doing these basic steps to isolate the x squared. All of this is good, but this is where it changes. Now, same thing, I'm going to take the square root, but we cannot take the square root of a negative, and we learned that yesterday. The negative is going to sneak out front and become the cursive I. And I want you to raise your hand if you recognize, what did I forget to do here? It's a common mistake I see students make. What did I, plus or minus, good. I'm going to have two answers, plus or minus. We still have to go ahead and simplify this 8. So just like we did above, I'm going to simplify the 8 into 4 times 2. And although mathematically there's nothing wrong with this, there is a better way to write it. So the proper way is to take this integer value and write it in front, and then followed by the I and the radical symbol in back. Now either one of these, they're equivalent, they both would work, but this is better. Talk about solutions and what type. Let me go back to the first one. Here I have two solutions and they're both real. Let's go to the next one. Again, I have two solutions and they're both real. My third and final example, I have two solutions and they're both complex. I know they're complex because they contain an I. Okay, we're going to dive into what Mr. Leone worked with you yesterday, and that was adding, subtracting, and multiplying complex numbers. Let's get started. Please watch the first one. Do not write it down. what is in front of this parenthesis? It's really like a positive 1. And multiplying or distributing a positive 1, it doesn't change anything. So as you watch, I'm just going to write this out in a line. I have 4 subtract 6i plus 7 minus 11i. And then I'm going to combine like terms. When I combine them, I want to order them with the real portion first and the complex or imaginary portion of the complex number second. So first I'm going to circle the real portions. 4 plus 7 is 11. Then I'm going to put a box. This is just for me to identify. These are the imaginary portions. Negative 6 and negative 11 gives me a negative 17i. These are the combined. 11 plus 17i. It's complex. This is the real portion. This is the imaginary. Come back either second or third hour for me, okay? All right, here we go. So I'm going to go through it. I'm going to distribute this. I have 5 subtract 11i, subtract 12 plus 6i. I'm going to go ahead and circle my real portions. Positive 5, negative 12 is a negative 7. I'm going to box in the imaginary portions. They're different signs. I'm going to subtract negative 11 and positive 6. It's going to give me a negative 5 with an I. This problem looks different. We have an expression that's different than the 2 previous examples because there's not adding or subtracting in between. So we're taking the product of these 2 expressions. And we could use the FOILing method. I find that most students do a lot better using the box method. So I'm going to take 2 plus 3i and I can line it up on top or vertically on the side. So positive 2 and a positive 3i. On the side then is 5 and a negative 7i. What we have to remember from yesterday's lesson is that I squared equals negative 1. That's what we have to memorize. So I'm going to get started by multiplying. 5 times 2 is going to go into this space. 5 times 2 is a positive 10. Into this next space is a positive 5 times a positive 3i, which is a positive 15i. Our next spot is going to be a negative 7i times positive 2, negative 14i. And our final space is negative 7 times positive 3. Okay, that's a negative 21, but then I have 2 i's. I times I is I squared. Now I need to keep going here. I know that I squared is equivalent to negative 1. So now I have negative 21 times negative 1, which equals positive 21. When I combine these, I want to write it in the form a plus bi. That means the real portion first and the imaginary portion second. So I have 4 different terms here. I'm going to circle the real portions. Positive 10 and positive 21 is 31. And then I'm going to box in the imaginary portions. Negative 14 and positive 15 is a positive 1i. If you just put 31 plus I, that's equivalent to 1i. If this value is anything other than positive 1, what we know is that we know that I squared is equivalent to negative 1. So whenever this value up here, we're evaluating this without a calculator, whenever this value is not even, evens are 2, 4, 6, 8. Whenever it's not even, the first thing I'm going to do is subtract 1. So I'm going to subtract 1 and I'm going to pretend that I'm only working with x to the 10. And I know that I'll deal with that x to the first later on. Remember, x to the 10 times I to the 10 times I to the 1 is the same as I to the 11. Now you also have to know 2 other facts. So if you don't know these facts and you have paper out, you definitely want to write it down. An even number of negatives always produces a positive answer. An odd number of negatives always produces a negative answer. And this shortcut is assuming that you know that fact from 7th and 8th grade. And if not, it's never too late to learn. So ready? Here's what we're going to do. Because this number was not even, I'm going to bump it down. And I'm only concerned with this. The next thing is I know that i's come in groups of 2, I times I. And I know that I times I is negative 1. So I'm going to ask myself how many groups of 2 fit into 10? And the answer is 5. 5 is an odd number. That means I'm going to get a negative answer. This portion equals negative 1, and I have 1 I left over. So I to the 11th is equivalent to negative 1 I. So I'm just going to demonstrate right now because on an ACT, you get to use your calculator. second I, I'm going to raise it to the 11th power, and we can see it's equivalent to negative 1I. Okay, please only watch this next one. I to the, let's go with I to the 17th. I to the 17th. 17 is not an even number, so I'm going to rewrite this as I to the 16th and I to the 1st. Forget about this portion right now and only worry about I to the 16th. I'm going to take 16 and divide it by 2 because I know that the i's come in groups of 2. 16 divided by 2 is 8. 8 is an even number, which means I'm going to produce a positive answer. So this produces a positive 1, and there's an I left over. Okay, on your paper, please write down the next one. Please write down I to the 23rd. I to the 23rd. All right, so I to the 23rd, because this is not an even number, I'm going to rewrite it as I to the 22nd, 1 less, and then I to the 1st. I'm going to take the even, forget about the I right now, take the 22, we're going to divide it by 2, and I get 11. So there's 11 groups of 2, 11 groups of I, groups as in 2, groups of 2, pairs of I's that fit in. 11 is an odd number, it's going to produce a negative answer. So this is going to produce, this portion is going to produce a negative 1, and there's an I left over. The next one we're going to practice as if it is a quiz question. You ready? I to the 47. Begin. So I take 1 away, I have I to the 46 and I to the 1st. I'm going to take 46 and divide it by 2, and that gives me 23. 23 is an odd number, and so I'm going to produce a negative 1, and there is the I. So every one that I've produced right now, I've been giving you an I that has an odd number, because those are the tough ones. Now let's go ahead and let's do some even ones. So let's go I to the 6th, I to the 6th. When this value right here is even, we don't need to take 1 away. See, we always took 1 away to make it even. We took 1 away to make it. When it's even, we just go 6 divided by 2. 6 divided by 2 is 3. 3 is odd. It produces a negative number. So I to the 6th is equal to negative 1. Let's do another one. I want you to do I to the 12th. Go ahead, please. I to the 12th. Is already even, so I can just take 12 divided by 2, I get 6. Okay, 6 is an even number, it produces a positive answer. This is positive 1. Let me flip this paper over to the side, and I'm going to give you 3 more, and let's see how you can do on these 3. So these are going to be realistic quiz questions. You ready? Here we go. I to the 15th, begin. Is not even, so I'm going to take 1 away from it. I know that I to the 14th times I to the 1st is the same as I to the 15th, and I'm only going to focus on this one. Taking 14 and divided by 2, I get 7. Does this 7, knowing that 7 is odd, produce a positive or negative? A negative. So I know this portion is negative 1. Oh, don't forget about the I. Last one, and you're on your way for today. Last one. Here we go. I to the 22nd. Is already even. It makes our life easy. We're going to divide 22 by 2 to get 11. Since 11 is odd, it produces what? A negative. This is equivalent to negative 1. Now, you may have somebody in your group that's like, why am I not putting an I here? What is the reason, guys? Why am I not putting an I here? Negative 1 is correct. The reason is because this wasn't an odd number. If it was to the 23rd, we would have broken it into 22 and 1, and this would have produced the negative 1, and then we had this leftover, but there's no leftover i's. it was an even number to begin with.